Here we have honest pre-calculus problem on the board. Okay, let's go over the question. Given the function f of x equals to 4 times 1/3 to the x to the power negative 16, the y-intercept of the graph of y equals to f inverse of x to the nearest hundredth. Okay, there is a function given that is f of x equals to 4 times 1/3 to the x to the power negative 16. And we have to find y-intercept for f inverse of x. Okay, so our first work is to get f inverse of x from the given function. Okay, let me write the given function as it is. It is f of x equals to 4 times 1/3 to the x to the power negative 16. Okay, to get f inverse of x, the first step what we need to do is we have to replace this f of x by y. Then the given function will become y equals to 4 times 1/3 to the x to the power negative 16. Okay, in the second step, we have to switch the y and x. That is, at the place of y, we have to write x. At the place of x, we have to write y. So then I'll be getting x equals to 4 times 1/3 to the power y negative 16. Okay, now in this equation, I have to solve for y in terms of x. Okay, for that, we have to isolate y. So let me add 16 to both sides to get rid of the negative 16 on the right side. So negative 16, positive 16 will cancel out. I get x positive 16 equals to 4 times 1/3 to the y-th power. Okay, now to get rid of the 4 multiplied over here, I have to divide both sides by 4. Then this 4 will cancel out. So I'm getting x positive 16 over 4 equals to 1 over 3 to the power y. Okay, now, so we have the function in the form x positive 16 over 4 equals to 1/3 to the power y. Okay, now how do you have to solve for y in this one? So what we need to do is we have to convert this equation to logarithmic form. Actually, this equation is in exponential form because we have the variable y at the exponent. So if I convert this equation to logarithmic form, I can solve for y in terms of x. So for that, what I need to do is I have to move the base over here on the left side to the left side of the equation. If I move the base 1/3 to the left side of the equation, it will become log to the base of 1/3. So that is the resulting equation will be log to the base of 1/3, and the stuff on the left side which already exists will become the argument of this logarithm. It is log of x positive 16 over 4 to the base 1/3. So the exponent y will become the base on the other side. I mean on the right side. Okay, now I've solved for y in terms of x. Better we can write the result as y equals to log x positive 16 over 4 to the base 1/3. Okay, now y has to be replaced by f inverse of x. This is the last step of finding inverse. That is f inverse of x equals to log the base 1/3. The argument is x positive 16 over 4. Okay, now I got the f inverse of x, the inverse of the given function. So our target is to find the y-intercept of the inverse function. To get the y-intercept of this inverse function, I have to plug in x equals to 0. So, okay, now let me do it. That is, I'm going to plug in x is equal to 0 into the inverse function to get the y-intercept. So when I plug in x is equal to 0 on the right side, we have log to the base 1/3. So 0, when I plug in x is equal to 0, it will just become 0 positive 16 will be 16 over 4. Okay, so f inverse of 0 equals to, when I simplify this one, it will become just 4. Okay, almost I got it. So the y-intercept is log 4 to the base 1/3, but we don't find this one in options, so we have to simplify to a numerical value like the one we have in the options. Okay, so for that we have to get the value of log 4 to the base 1/3. Usually in our calculator, we'll not be able to get a value for logarithms with bases like 1/3 or something like that. So usually in our calculator, we'll be able to get values for logarithm if the base is 10, that is common logarithm, or the base is e, that is natural logarithm. Usually natural logarithm will be spelled as ln. Okay, so either we have to change, we have to change the base, the 1/3, to either the common logarithmic base 10 or e, the natural logarithmic. So, okay, I am planning to convert this base 1/3 to common logarithmic base, that is 10. So what should I do to change this base 1/3 to common logarithmic base? So very simple, I just have to write 2 logarithms in division. So for the first logarithm, whatever argument we have over here, the same argument should be taken. And for the logarithm in denominator, I have to take this 1/3 as argument. Now for these 2 logarithms, whatever base I want, I can take it, but I have to take the same base for both the logarithms. Okay, so since mine is to get the value for the logarithms, I'm taking base 10. for the logarithm in numerator and logarithm denominator. Actually, this is a concept of change of base of logarithm. Okay, now we can use our calculator to get the value of log 4 because now the base is 10. So it's a common logarithmic base. So the value of log 4 to the base 10, I'm just rounding the value of this log 4 to the base 10 to 4 decimal places. Then I'm getting 0.6021 divided by, and so to get the value of log, log 1 over 3 to the base 10. So first we have to simplify this one. That is actually in argument we have division of two numbers, 1 and 3. So you can use a coefficient rule, that is log 1 negative log 3 to the base 10 to the base 10. Here 0.6021 divided by, so the value of log 1 is 0 because whenever the argument of a logarithm is 1, its value is 0, negative. So the value of log 3 to the base 10 from the calculator is 0.4771. Okay, so f inverse of 0 equals to 0.6021 divided by, so the simplification of this one is just negative 0.4771. So when I divide 0.6021 by 0.4771, I'm getting value like 1.26199. It keeps going. I just round to the nearest hundredth because the question says round the value to the nearest hundredth. And since we have a negative sign in the denominator, so this value will have negative. So now I got the y-intercept of the inverse of the given function. So that is negative 1.26. So the correct answer choice for this question is option A.